Now we move to 7.4, moment of inertia for an area by integration. So step number 1, we need to identify the element dA. So dA here, we choose vertical strip or horizontal strip. Do you remember before we analyze by using the small element, right? Like this. So like this, we have the X, we have the Y, and this is the entire of area, and this is the small dA. So we have here is X, and then this is Y. So this one is become dx, and then here become dy. So when we analyze, we want to get what is this small area dA is become dx dot dy, right? And then when we want to calculate, we want to determine the moment of inertia for this small. So we have dix square to y squared dA, and then the small one dy square to x square dA. Right. So now from this small cube, we transfer to become rectangular strip. Okay, so now when we use the rectangular strip, we have to choose is either horizontal strip or vertical strip. So to be memorized, if you want to determine the Ix, moment of inertia about x-axis, then we can use the horizontal. And then if you want to determine the Iy, okay, moment of inertia about y-axis, then we can use the vertical strip. Okay, so this example show that we choose to use the vertical. So now this is the vertical strip. So this vertical strip, this is the element. So what is dA here? So dA here is equal, okay, so this is the dx, and then this is the y. Okay, this is y, and then this is x. So dA is equal to dx dot y. And then what is the moment of inertia about Iy? So for the rectangular strip, we have diy is equal to x squared dA. Right. So it become like this. diy is equal to x squared dA is dx dot y. So when we want to determine the entire, Iy square to x square dot y dot dx. Okay, now for the next moment of inertia about Ix, about the x-axis. Okay, so if you want to use horizontal, it will become like this. This one is vertical, right? So I want to show you later. So now if I want to show you, if we choose, if we want to have horizontal, it become like this. So this is the dA. So if we have the horizontal rectangular strip like this, so this is become dy, right? So this is x, this is y, and then this is y, and then this is x. So the small dA here, the strip dA here is what? X dot dy. Right. Then what is the moment of inertia about Ix? So for the strip, moment of inertia about Ix is equal to y squared dot dA. So now we have dA is like that. So for the entire area, so we can have that Ix is equal to y square dot dA is equal to y squared dot x dot dy. Okay, if you choose the horizontal, however, we can use the same vertical analysis like this for determine the Ix. Okay, how to do that? So we can apply for the rectangular area like this. Okay, we can apply the rectangular area like this. So this is rectangular area x, y. So this is 1. So let's say here is h. Let's say here is b. And then this one is dy. And then this is y. Alright. So what is this dA? So this dA is become b dot dy. This one, right? This is b. This is b. Okay, b dot dy. And then we want to determine the moment of inertia about Ix is equal to y squared dA. So now we have dA, so we substitute this one into this. So we have y squared dot b dy. So the limit here is from 0 to h. So you can have that 0 to h. So we can have like this. So we have here 1 power of 3 divided by 3 dot b 0 h. So we can have simplify b h power of 3. So this is the Ix. Moment of inertia about x axis if we want to use this vertical strip. Understand? So that is why here you may see this is the shortcut lah. This is the shortcut. So if we use the same vertical strip, then we can have that moment of inertia is equal to small element of moment of inertia, and then we can get that 1 over 3 y power of 3 dx. Means that we still use the same vertical strip like this dx. Okay.